Building Software for Production with Martin Thwaites.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure. And by the way, they are hiring software engineers, and they're a full-service software architecture and engineering firm empowering software delivery for business-critical projects. And quick announcement, my architect forums are still going strong. Signups for the next session are up. And if you lead software developers and you're looking to collaborate with other people who also lead software developers, then just go ahead and sign up at the link in the show notes. And for those of you who are looking for Programming with Palermo, my video podcast, just search for it in any of the directories and you'll be able to find it. My guest today on the show is Martin Thwaites, and he's a developer advocate at Honeycomb. He's an Ollie enthusiast, which is observability. And he's a delivery-focused developer from the UK. With over 20 years experience in development in the .NET ecosystem, he's worked with many companies on scaling up engineering teams and products. And the past few years have been spent working on solving complex problems with some of UK's big names, including e-commerce retailers and credit lenders. So, Martin, welcome to the show. How are you, sir?
I am absolutely amazing. Thank you for having me.
Oh, very good. Very good. Well, before we get into building software for production and observability and lots of goodness there, I want the developers to kind of make sure they know who you are. And you recently spoke at the Kansas City Developer Conference, among other places. But kind of back up a little bit, what are some of the high points in your career that you credit for pushing you in the direction to work on the things you're working on today?
So I put a lot of this down to my entry into tech, which is not a traditional entry into tech. I came into tech through testing, and I started out because it was, well, I mean, you go back a little bit further. I was doing something called File Tab D, which is a programming language that nobody's ever heard of, which is a language all built around decision tables, like built for really high performance insurance algorithm stuff. I kind of came into it through that and then shifted into testing and doing automated testing, which I found really cool because you could do so much. I was like Selenium 0.2 beta way back. And I came through testing and started seeing some of the limitations of frameworks and then started building my own frameworks around stuff. So I started building a framework around Selenium using NUnit, for instance. And that kind of got me into tech. And I think all of that has really influenced where I've gone with technology. I moved all the way through like when systems analysis and then building software myself, running teams, building software. And probably the most prominent would be I worked for Manchester Airport Group and I built their digital division we had 2 team members before I started. When I left, there were 70. And I interviewed and built all of that team with this idea of mainline development, building with weekly sprints, if you can call them that. All that idea of like rapid software development, iterate, build it, deploy it, test it, A/B test, testing in production, all of that kind of stuff where you can do it all safely. Which is, I mean, incidentally, the airport was where I first learned about Honeycomb, when I started talking about what we were doing at the airport, which was all about how we used logs and metrics to do all of the awesome stuff that we did safely. So, because, that's the whole scary thing, isn't it? It's like you talk to people and they go, mainline development. Well, no, you do it in a branch and then you wait 3 weeks for somebody to review it. And then they come back with some changes and then you do the changes and then another 3 weeks passes and then eventually you deploy it. And then you tell them, no, you don't need to do that. It's like you just commit to main and that will then deploy all the way through your environments and then it'll go on production. And if something goes wrong, you do the same thing again. And it takes 15 minutes to get there. And it just blows people's minds. And I started talking about this at conferences and user groups and stuff like that. And then I got introduced to Honeycomb. And I was like, oh, this is like all of those, but better. And then, just started going through consulting and doing organizations, doing the same thing other organizations. And that's kind of where I ended up, really. Just everybody trying to replicate these sort of things and replicate everything I did at the airport at various other companies around the UK.
Okay. So to get into that, before we kind of dive in, just so that people know if they've never heard of Honeycomb before, what are some of its other peers, just so you can kind of generally classify where it sits in the product space? Honeycomb is like, of course, but better, but Honeycomb is like what other products?
Okay, so there's sort of probably concepts people have heard of, like APM, monitoring, metrics.
Mm-hmm.
Those are terms people have understood.
And APM is application performance monitoring or management, just to do the acronym?
Depends who you ask.
Okay. Right.
But generally, it's about this idea of I install something and then I can see what's going on.
Yeah, what's it doing?
That's kind of where the APM stuff comes from. Monitoring being what you do afterwards.
Mm-hmm.
And it all falls under what's now been termed observability, or OLI. For short. This idea that observability is this idea that you can ask questions of your production systems and get those answers from the outputs of your production system. That's really at the heart of what observability is. Honeycomb is a company that was built around that concept, and it was built to kind of disrupt the idea of APM and monitoring and this logs and metrics and just big, massive data stores of logs that you trench through and maybe never even look at. And it was built to disrupt all of that. And they built a engine, Charity and Christine, built this whole engine that's only built for observability type data. So they're a company that's built around that, and it's been built. We've built features around it and expanded it, and that's where we are now. So
you guys compete with what? Datadog, Splunk, New Relic, Application Insights, kind of generally?
Yeah, I mean, same sort of space. We're kind of trying to solve the same problem, just in very different ways, which is why we don't talk about them as competitors. They're trying to do the same thing that we're doing, as in we're trying to solve the same problem, which is how do people understand their production systems, which is where the whole talk that I did at KCDC came out with, because this is all about how do we support our production systems. We just do it in very, very different ways.
Now, I learned something today, and I'm sure the other listeners. It's this word O11Y. And it looks like Ollie, O-L-L-Y, but it's O11Y. And it looks like it's a takeoff of how Kubernetes is K8S. And do you actually know where that came to be, where the number is the number of letters we're kind of skipping? And we just, do you have any idea?
No idea, but I mean, I would say accessibility predates that. So Ali.
Okay. Accessibility. And so A11Y.
Yeah. And you've also got internationalization, as in I18N, which is where you see in lots of stuff, which I would imagine is them just trying to save characters in namespaces, right. Which saves companies money, because when companies charge by the character that you write, writing I18N was probably saving the money at the time.
Okay. All right. All right. So if anybody hasn't seen the O11Y, that stands for observability, just like those other words. All right. So let's get into this. We obviously want to know what our software is doing in production, but what's the foundation? What has to start first? And that whole mindset of stable software, reliable software, we know what it's doing. It's not crashing, falling over, throwing errors. What are the foundational elements, and kind of walk us up from there? So
the idea is that what we really want to know is, how is our system performing in production? That's really what we're trying to do. But the underpinnings of that are really, are users affected by what our system is doing in production? And this all comes down to people who monitor the CPU metric, and they worry when it gets to 90%. Well, really, you shouldn't, because what you should be really cared about is, are your customers being affected by you sitting at 90%?
Yeah.
And that's really what reliable software is about. If you work in the cloud, for every percent of CPU you're not using, you're wasting money.
Right.
You should treat cloud servers like you treat a rental car. You should grind the gears, rev it, because you're going to give it back. And you don't care. You don't have long-term maintenance to think about.
You said out loud what other people think in quiet.
Yes, I said the quiet words out loud. Yes. But that idea that what we should be caring about when we talk about production is the customer being affected, is the customer's request going slower than it normally would.
Yeah.
That's where the heart of observability is about, is being able to ask some questions that we didn't ask questions that we didn't know the answer to.
Mm-hmm.
Because we didn't know we needed to ask this question. So when you're in production, if you know that you've got some routes that are a bit slow sometimes, you'll probably put some metrics around those so that you get some alerts that say the auth route is running slow today. What you don't know, though, is why that auth route is slow. You know the auth route is slow, but you don't know why. You don't know that actually the auth route is slow because we got an influx of customers from Norway that were hitting our US servers. So actually, yes, it's expected to be slow. Now, the reality is you maybe didn't put a metric around the auth route and the user location, because that would probably be a waste of data. And that's really where we come to with asking these questions that we didn't know that we needed to get the answer to. And we use things like tracing as a way to get that. Because if we can store all this data as really wide events, then we can ask any question that we wanted to ask. So that whole idea of, if you are scared about production, you're scared to deploy something, it might go wrong. Why are we scared? Well, the problem is that you don't know how to find out why it went wrong, which means that you're scared of it being down for a day, a week, rather than scared of it being down for 15 minutes, because immediately you know what the answer is. Yes, we just deployed something, and yes, that was the problem. Or we deployed something last week, and all of a sudden we've just turned it on because we're using feature flags like we should. And then, oh, we've turned it on now and it's gone wrong. Or even worse, a customer's onboarded. That was no change to the software that we wrote, but we just had an influx of new customers because somebody was at a conference and started talking about observability, and everybody went, well, let's go buy Honeycomb, because that's what I do at conferences.
Right.
But you get this massive influx of new customers that you weren't expecting, and all of a sudden they're doing weird stuff. Like you don't know what customers are going to do when they get hold of your software.
Right.
We have this idealized vision of the customer's just going to click that button and then they're going to click that button. And then the customer comes on and it's going, I'm not going to click any buttons. I'm just going to select the whole page and I'm just going to refresh. You're like, no, click the button. If only customers did what they were told. Like,
Right. So there's a lot of language in here that is specific for web applications, but for smartphone applications or desktop, mobile, what of these concepts are the same and what's different?
Exactly the same. Everything that I've talked about there is exactly the same. You've deployed some software. I mean, it actually gets even worse when we start talking about client-side stuff. Now, that might be client-side browser, or it could be client-side in terms of desktop apps or mobile apps. You're asking the same questions. We've released a new version of the software. All of a sudden, it starts crashing. Well, I need to know individually what device it is. Now, if you've added a metric which has a data point as a label on it for exactly the OS version and the device and the metrics and the resolution that was being used, that's incredibly what we call high cardinality. There's hundreds of thousands of possible values of that intersection of things. So you've got that same problem of, well, I want to know what was going wrong. Oh, it turns out it's actually only the Samsung S7 Pro tablet when it's in landscape mode. that was actually the problem. And it has to be on Android 13.3 in order for this error to occur.
Yeah.
It's that same idea that we've deployed some stuff. Maybe a customer was working perfectly fine and then they upgraded their device and now it's going wrong, something that you don't control. And that whole concept around observability is how do we ask the production data, whether that's your databases or your logs or your metrics or your traces, it's how do we ask of that data, why did it went wrong? Why did it go wrong? You ask them, well, where does it hurt? You're asking your system like you would a human. Like, where does it hurt? Tell me where it hurts.
Okay.
Tell me who hurt you.
Let's ask that question. Let's say that something fell over. How do we know what exactly happened?
So the idea that behind observability is what we call unknown unknowns, which is the things you didn't know that you needed to know about. You do that by adding more and more context. We talk about tracing. So tracing is the idea that we can take an entry that happened, and then something else happened, and then something else happened, and then something else happened. Now, the way that we do tracing is slightly different to logs, which are a linear idea. We do them as structured events, just the same as you do with logs. But we also do something called causality, which says that this thing happened because this other thing happened. Now, once you've got all of that data, you have this, what we call a trace waterfall, which is the idea of something going down in a diagonal. You can see that the lastmost thing is normally something like a database call. The topmost thing is your customer request.
A click or something.
Yep. And then you widen that out and you do this with wide events. So you start adding more and more context. So right up at the top on your user event, you have things like the position the button was on the page. You might have the browser version, you might have the Android version, you might have the location that the user was down to GPS coordinates, if that's something that you can take if you're not in the EU, because we don't allow that stuff. All of that data, you add tons of it, tons of context. We call them attributes in tracing. You add tons of attributes. The more attributes you add, the more context you have.
Okay.
The more context you have, the more questions you can ask.
All right. That all sounds great. How do I get set up to even be able to do that? Is that a whole lot of custom coding that needs to be added to the application? How do I even get started with this, what's now seeming this huge observability topic?
So that's where something called open telemetry comes in. Previously, this would have been proprietary agents. It would have been, I choose a vendor, and that vendor will then provide me with some kind of SDK, some jar file if you're in Java, some pip package, or in .NET, you'd get some NuGet package that you'd be able to install in your application. Great, now I've got a load of data. Now that came with what we call a APM. An APM was this idea of I'm going to treat every application pretty much the same. The issue is there that you can't add then custom context easily. And you also can't move vendor very easily either, because you have to deploy a new version of your app in order to be able to change where you're going. You have to change a lot of custom code. Open Telemetry is a new initiative. It's number two project from the Cloud Native Compute Foundation, behind this small project they did called Kuba something. It's about containers. Kubernetes, I think it's called. Yeah, something like that. I don't know. Popular with people, apparently. But it's their number two project. And it's this idea of how do we generically get telemetry out of our application, whether that's an Android app, a client-side JavaScript app, a back-end .NET app, a back-end Go application. How do we do that generically with some SDKs? Now, the other thing they've started to do is something called auto-instrumentation, or agents. And that uses various technologies to sideload telemetry and grab a load of stuff without you writing any code at all. You literally write something into your Docker container, and then you get a whole host of the sort of telemetry that we used to have with APMs.
Okay.
The idea of treat everything the same. The advantage, though, is that we can now easily go and add additional telemetry, the stuff that's specific to our application. We use resources files in .NET. So I'm going to add the specific resource file that we were using at that time. I'm going to add in the specific version of the the packages that I'm using.
Mm-hmm.
I'm using Mediator, so I'm going to throw in some Mediator specific information. My user ID exists here, and I've got these groups on my user. I'm going to add those into my telemetry. And that makes it a lot easier. So you start with something really easy, sideload in something like a .NET agent into your application, and then you can go further with that and then add your custom things on top of it. So in answer to your question, is it loads of code? No. To get the basics, it's not. To add your context is then incremental.
Okay.
So it doesn't feel like a lot.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Okay, so when you talk about adding in the extra context or adding in the extra attributes, I imagine that the naive way would be every screen, every bit of code that does some logic, you sprinkle in a few extra lines of code. But maybe a better way is at the edges of your application where you integrate with your authentication, or you integrate with Mediator, or when you integrate with other libraries. At that point in time, you add it in. Or where is the most appropriate place to add in all these different attributes?
So what I'm going to do now, I'm going to draw on my 3 years as a consultant and say, it depends.
Oh, thank you for shining light on the situation. My eyes, the scales have fallen.
It really does. And this is where APM and observability differ. Because APM treated all the applications the same, and they could quite easily come up with an answer to that question, which was add it here, job done, we'll do it for you.
Sure.
With observability, this is about bringing your context in. I don't know how you built your application. I don't know how many layers are in your N-tier architecture.
Sure.
I think the popular thing is 72 layers in N-tier architecture because N is a number. So, but I don't know how many layers. I don't know whether you're using SQL, whether you're using NoSQL. I don't know whether you've got some caching layers in. I don't know which ones of those are going to be more important or less important to your application.
But you mentioned authentication. If someone logs in at the beginning of the session and then they do stuff, I'm guessing at the point where they log in would be at the appropriate time to add in some information regarding the user?
Yeah. I mean, if you've got some information at that point, but it's really wherever you've got some information.
Okay.
The thing I think that shines really with open telemetry, which is one of the reasons why, also more specifically tracing really, which is one of the reasons why the talk I gave was bringing in observability into the testing cycle, is everybody has this sort of crown jewels of their application. And it's that part of their code that they're really proud of, that does something really interesting. And that's really where the IP of an organization exists. And that bit of application code, if it goes slower, we want to know about it.
Yeah.
If it's returning the wrong results, we want to know about it. And that's really where you want to be thinking about adding loads of context. Because the more context you've got about the entry point into that bit of crown jewels, maybe it's the groups that a user was in, maybe it's the origin of that particular user. Maybe it's when they signed up. Maybe that's important. Maybe it's the feature flags that particular user or their organization has turned on at the time when they tried to make that particular request through your crown jewels algorithm. Because the more context you've got, the better questions you can ask.
Okay.
You can ask that question and say, when this goes slow, what's the commonality? And it says, well, actually, it's when these 3 feature flags are turned on and the user signed up 3 years ago or more.
Mm-hmm. Yeah.
And that is gold for an application developer. I mean, I've been working in application development long enough to have had the ticket that says Dave's having a problem.
Right. And only
to
Dave.
which I responded with Martin isn't. Apparently that's not the way to respond to a customer support ticket. But that idea of somebody's having a problem, it's like, I need a bit, just give me a bit of information.
Right.
And the more information you've got as an application engineer, the quicker you can fix it. The quicker you can fix it, the more confident you feel about deploying things. The quicker you can deploy that, the more confidence you have about deploying it. And then that cycle just gets so much quicker. It's like that flywheel of things. It's the more that you do of these little things, all of a sudden you just gain so much more confidence. And that is where that whole idea of build software for production, build software that's observable.
Yeah.
Which all feeds into that operable software.
Sure. Well, one thing that I've learned when you get that support ticket or it's escalated to the development team past first line, someone has a problem and you get connected with an actual end user, the best first words to say is, I believe you. I believe this isn't working. I believe that you're not able to get what you want done. All right. I need to learn how I can beat the computer into submission. Can I get some information? Because so many users get questions and it almost comes across like, well, it's working for everybody else. It must be your fault. It must be the user problem. Everything must be fine and you must be the problem, Mr. User.
Yeah. So, I mean, there is quite a few times where I've wanted to respond to a ticket with, this is a picnic error, which stands for problem in chair, not in computer.
Picnic. That's another one for the PEPCAG too. Problem exists between keyboard and...
Yep. Picnic I find as a little bit more user palatable.
Picnics are nice, right?
well, PEPCAG sounds like you're calling somebody a name.
Well, yeah, that's not a pleasant word, PEPCAG.
Yeah, but picnic sounds like, it's a picnic area. This is a walk in the park. It's fine.
Exactly.
Okay,
so I want to pull back all the way to the beginning of our conversation when you were saying, okay, given you all have this in place and you've done everything that you need to do, you should be able to commit to main. And then after that happens, we just kind of deploy to production because everything's hunky-dory and everything works as if it should. I think there's a few steps in between for people on their journey to that. And so
there's coffee in the middle, maybe
there you go.
Sandwich.
So I want to understand, in order to reach the practical reality where you're safe, actually committing to main, I want to know the mechanics of, do you mean that every single commit is committed to main and pushed, or do you commit locally, group them up together, and then execute a push? What are you actually seeing people do from a practical perspective out there?
There's a scale.
Okay.
The main thing for mainline development is that you're not having long-lived branches. That's kind of
Before you said no branches. Now you're saying branches.
Yeah, I know. And that's why I mean there's a scale. Because realistically, at the heart of what we're talking about is we're trying to get our code integrated. If you think back to what CI was initially, if you have branches, you're not doing CI. It's kind of that old school rule. The
absolutely continuous, all the time, never pausing.
Exactly. Yeah. You are always integrating your code with the main branch, with everybody else's code continuously.
Yeah.
And as soon as you abstract that away with a branch, the idea was that, yes, you're doing it wrong. And yeah, you want to go back to that original definition? Yeah, absolutely. I don't care about that definition. What I care about is the software makes it to production and is safe. It's operable. It's something I can understand. Mm-hmm. So the scale goes, people will start a branch at the start of a sprint. They'll work on their stuff for 2 weeks with 3 other people. They'll be committing all of that code to that branch.
Too much.
Then they will try and merge that code into main, having never touched that particular, never touched the main branch for 2 weeks. Mm-hmm. And then you get a load of merge conflicts.
Yeah.
And you've got thousands of lines of code that are being merged in. And that's, I see, where a lot of the fear comes from.
Yeah.
Because I'm merging in 10,000 lines of code that have changed in 20 different areas of our product.
Mm-hmm.
Well, yes, that's scary.
That is.
I believe you. I believe you are having a problem.
The merge won't finish. Too many conflicts.
So the idea is that we merge often and we merge small.
Yeah.
So I regularly use branches on my local machine to stash some work. I have them for myself. I don't collaborate with branches.
Mm-hmm.
I don't have 4 or 5 people committing to a branch. I will merge at least daily back into the main branch. Now, that might seem scary to some people, that if I say that as soon as I've merged into main, it's going to go through some processes, but it is going to go to live.
Mm-hmm.
There's no, it's going to go into main, we're going to bunch it up, and then on Thursday, we're going to have a meeting about whether we're going to push all of the thing that's in main onto the main branch, onto the production system.
Mm-hmm.
No, it will go out if it is merged into main. Which means that any time that you need to do a fix because something has gone wrong, the way that you do it is you merge something into main, which means main is always clear.
Yeah.
If somebody turns around and says, we've got a bug in production, you go, right, I'm going to branch off main, I'm going to fix the bug, I'm going to push that back into main, job done.
Yeah. Because
main is always clear.
Yep.
And you might say that Git flow and all of those kind of GitHub flow, Git flow. I lose track of how many different methodologies people are coming up with to solve mainlining being a potential problem.
Yeah.
But mainlining or trunk-based development is kind of this idea of small, shortly lived branches that we iterate on quickly.
I also have a few gray hairs, and I remember when continuous integration was being debated about, like, should we? And I remember 2005-ish, 2006, and cruisecontrol.net, and like Team City wasn't even out yet, much less the other ones. And at that time,
I remember the little tray icon from Cruise Control.
Right. And the merging chicken, like I'm merging, but back then, most of the source control technologies were centralized. And so if you were committing, you were doing a server activity, and that those were one and the same. Whereas today, we just assume Git doing a commit is not a merge on the server activity. Like the source control change has inherently given us this option of give me a personal fallback point if I need to, okay, it's working now. Let me lock that in. Now let me try something else. And then I still have to do a push to actually then, boom, push it onto the server. So the original continuous integration, there wasn't even this option to have this kind of personal stuff unless you did a branch. So I just want to recognize that. And then,
shelve sets from TFS way back in the day. That was that watching people switch from TFS onto Git.
Mm-hmm.
That was one of the hardest migrations that I ever did. Was moving a TFS code base onto Git. The problem wasn't moving the code base. Moving the code base was easy.
Mm-hmm.
I mean, trying to get the change history into Git change history with all of the scripts, that was an experience. But the main problem was people understanding that I've committed my code, and you go, but where is it? It's like, well, I've committed my code. It's like, okay, but it's not on the server. I can't see it in GitHub, or even TFS backed with Git back then. It was, isn't that now become Visual Studio Online?
Which then became Azure DevOps and Azure repos, and it's all Git now.
Yeah. But they're like, well, I can't see it up there. It's like, well, you need to do a push. You need to push the branch. It's like, but I've committed it.
Right.
And that mind flip that people had to make was really, really hard. That idea that, well, the server, and this is where TFS really did some really good stuff at that point, because they incorporated Git in a way that helped that mindset of it still being a server operation.
Yeah.
I do my code, I push it up to that repo.
Right.
I mean, I always chuckle when people say, that people think the source code used to be centralized and now it's not, it's decentralized. I'm like, where do you push your code? GitHub.
It's pretty
All
central.
Right. One place.
That's right.
What does the word central mean?
Right. So there's a few other things, and we got to kind of at the end of our time here, but from just making changes, getting merged into your main branch, your master branch very, very quickly, not long-lived departures, however you do your branching, but short-lived at minimum once a day. And that helps with knowing what's going on. But what in your mind, what are the minimum sets of testing and verification that need to go in this chain just to give people enough of a safety net to have that kind of process?
Okay, so this is where the most controversial one of my opinions comes up at the moment, which is I don't believe you need unit tests.
Okay, drop the word unit. What kind of quote, make sure it works steps would you advocate for?
Okay, so a friend of mine came up with the term developer test, which I think is the best term for the type of tests that I think are useful.
Okay.
Which is tests that exercise the user functionality holistically, end to end.
Okay.
And they do that in memory, fast, and they don't change things by reaching into the middle of your application.
Okay.
Now, in the .NET world, that's done using something called the Web Application Factory. So we spin up a web application factory. Normally we're working in smaller units nowadays. We call them microservices, call them whatever you want, but we're working in generally smaller units. We can spin up an entire application in memory using the web application factory. We can hit the API endpoints in the order in which the customers would hit them. And as long as we're doing that properly, we use a SQLite database in place of a SQL Server database. As long as we're hitting those endpoints in the right way, the same way as a customer would, then we should feel confident that our application is functioning. We don't really care about your repository implementation. We don't care about your mediator. We don't care about the command query separation that you've got going on.
Okay.
I don't really care. What I care about is that the APIs work, which comes back to taking it all the way back to what we were talking about around the observability stuff, which is I care that my customers can hit the endpoints. I don't care that my CQRS implementation is broken. If the customer can still hit those requests, everything should be fine.
Yeah.
If we add the low-level tests, it means that our application becomes resistant to refactoring, because if you have to change your tests when you refactor, your tests no longer have any confidence. Because, well, I don't know. I've got new tests now. I don't have tests that tell me that it's still working the way it should. I've got tests that tell me it's working now. But if they're different tests than the previous commit, then I don't have that confidence. So if we're having to change tests as we go, then our code base is resistant to refactoring. It's resistant to change. So if we would take those tests and we take them above, but we still run them in the context of our application in memory without production dependencies, I'm not talking end-to-end tests where we would test 5 or 6 different microservices and how those fit together. What I'm talking about is hitting your APIs from that one service in memory, making sure that if you hit the add to-do API, that the get to-do API will bring back that to-do item. Now, I don't care whether you've got 17 layers of abstraction inside of your code or one or none. As long as those 2 actions work, that's fine.
That's a pretty concrete description, because by asserting that they should run in memory, you're inherently excluding trips to a database, trips to jumping basically anywhere else except in that single process. And so if you're putting those walls around it, those tests are inherently going to be fast, because most of the time is spent jumping across the network in any kind of logic, right? Yeah.
Oh, yeah. We have this debate all the time with performance of observability, where people go, oh, it needs to be really, really fast. I'm like, okay, are you hitting the database? It's like, okay, well, you've already added 5 milliseconds.
Right.
Observability adds 200 nanoseconds.
Yeah. Right.
And that is the idea that we should feel confidence in our application.
Mm-hmm.
When we bring in external dependencies like a hop to a Azure SQL database, or a hop to Cosmos, a hop to Service Bus, a receive from Service Bus, we're bringing in external dependencies.
Mm-hmm.
The only place where we know whether those are going to go wrong is in our production system.
Yeah.
We can do as much testing as you want in UAT. We have a saying, and I hope none of your listeners are below the ages of believing in things like Santa Claus and the Tooth Fairy. But the idea of Santa Claus, the Tooth Fairy, and a staging environment that matches production.
Right.
They're all mythical things.
Yep.
The only environment where we know where all of those interactions are going to be performing in the way that production is production.
Mm-hmm.
The rest of the stuff is your application logic, and you should test your application logic from the start to the finish of just that application logic.
Yeah.
But when I do say mock things out in the outer edges, I am saying use a SQL compliant database like SQLite.
Okay.
If you've got a SQL database, use SQLite.
Mm-hmm.
Don't mock out the underlying repository pattern that you've built underneath. Just use a proper database, but use one that runs in memory and fast.
Okay. Good tip.
If you're using Cosmos, you're probably going to have to write yourself a little abstraction that does that. That's one of the things that we did at one of my consulting contracts recently. And we had 8,000 of these tests running in under 10 seconds.
Yeah. As long as you stay in memory, it's pretty darn fast.
And if you do that, they can effectively replace all of your unit tests, because I don't care that you've tested the getter on a particular class.
Yeah.
I care that the user can still do those things.
Gotcha. Well, I think we could talk for an entire other episode on testing strategies. We'll have to leave that for another time. But Martin, thanks so much for sharing with us your views on observability and Honeycomb. So check that out. We'll include links in the show notes. But yeah, I appreciate you taking the time and coming on and helping us design applications that run better in production.
Awesome. Thank you so much.
My pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.